All right, we're going to start our radio setup. You want to start by centering the collective stick and make sure that you have no trims or sub-trims set on any channel. You also want to make sure that your throttle and pitch curves at 50% stick are set to 0, so that if you were to look at a servo monitor or if you look at your servos, they're all centered. If you look at the servo monitor here, you can see that the aileron, elevator, throttle, rudder, and pitch are all set to 0. That's where we want to start the setup. Just a note about the 750, if you're using an S-bus setup, which you pretty much have to, you'll have to make sure that you have the channels configured correctly to match your transmitter. You're able to go through the S-bus setup and then cycle through each function and make sure it's assigned to the correct channel on your transmitter. That way everything's getting the right signal. You need to do that before really you do anything else. If you're setting up a 750, first you want to go to the swash plate basic setup screen. You'll want to specify that this is a 120-degree swash plate. If you're using high voltage servos, you can set their type to 285 Hertz. Some of these have an analog digital setup. Depending on what kind of servos you have, that's what you'll use. This is a 700 class helicopter, so for the 750 we'll use this setting. And if you use servo direction combo number 6, it will automatically set up everything you need to have the collective and the cyclics move in the correct direction. Now we're going to fit our servo arms. You want to use a heavy-duty arm that's capable of a 19mm distance between the center and where we're going to put the control balls. Remember, the radio is now set up where everything is as close to center as we think we can make it. So you're going to want to fit all of these in a trial way on both the aileron, the pitch, the elevator, and the rudder and the throttle. If it's not centered, and you'll have to judge this, simply reposition it. If you're using something like this that doesn't have many positions, you've only got a couple of choices, you know, one upside down or right side up. If you're using something that has many arms, then you can move it around and get different positions. But we're going to set them all on here as close to center as we can, and then to get them perfect, we'll go to the next step in this. And the next step in this is to use the center functions when the flybarless controller. Futaba calls them neutral, and you have the option of changing the aileron, elevator, and pitch settings. I've made some adjustments on mine to make sure they're as close to center as I can make them. This doesn't change anything on the transmitter. It's still set to center stick with no trims. All right, once you find the center position on particularly on the swash plate servos, you're going to have to make some modifications to the arms. Because of the way the canopy fits, you can't have an arm that sticks out past the side of the servo here. So what you're going to want to do is take this off, and you're going to want to cut it like this. Just cut off everything that is superfluous. And we can go ahead and mount a control ball. It's going to mount on the inside of the arm. The kit comes with a 2.5mm drill. Drill it through the hole that's 19mm from the center, or make your own if you have to. Insert the ball, put some, in this case, green thread lock on it. Get that nut really good and tight, and then you can put that into position. You want to do the same thing with the aileron servo and the elevator servo. Once you get the arm set in the proper position, make absolutely sure you put the servo bolts back in to hold them on. You might want to use some blue thread lock with that if you have, particularly if you have metal, a metal axle in the servo. They will come off. You will crash the model. It will be ugly. Once those are in place, then the only thing left to do is to snap on the control links, and you're going to do that on all of them. Before we do the pitch curve setups, we want to make sure that the swash plate is absolutely level at center stick or 0 degrees pitch. So I've set the transmitter sticks in the center. There's no sub trims. We centered the bell cranks a little earlier. At this point, we're going to take a miniature aircraft swash plate leveler, or any other brand for that matter. And what we want to do is make sure we eliminate any gaps between the tool and the swash plate. You can see there's one here on the elevator side. There's also one on the pitch side. So going back to those neutral settings on the fly barless controller, I'm going to make minute adjustments there to get this out. These adjustments are too fine to move the bell cranks on the servos. Okay, I made an adjustment to the aileron and the elevator neutral setting. Now you can see that this tool fits flat against the fingers on the swash plate. It does on this side as well. One thing you want to be sure of is that the aileron and elevator gyro directions are correct. What you should see is if you move the model forward, it should correct backwards. If you move the model to the left, it should correct to the right. If it's not doing that, you need to change that, otherwise it will crash when you take it off. So at this point you can go ahead and put the rotor head back on. Make sure you tighten these two clamp bolts with blue thread lock. Snap on all the connectors, and we're ready to put the blades on. For this model, we're going to put on a set of Maverick G5 Pros, the 690 fly barless blades. If you have the fly bar rotor head, you'd obviously want to use the fly bar specific rotor blades. So once the rotor blades are on, you want to make sure that center stick on your collective sets the pitch on the blades at 0 degrees. You can check either both blades or a master blade, your choice on that. To get it correct, simply change the lengths on these rods. If you've made them both the same length, most likely you'll need to change both rods by the same amount. Once you've found the 0 point in the center, you can go ahead and use your transmitter to set up the pitch curves. I'm not going to go into the details of setting up a pitch curve other than to say, a typical starting setup for this would be 6 degrees in normal mode for hover point, with plus 10 as the highest pitch and minus 4 as the lowest pitch. And then set up an idle 1, typically 11 degrees positive to 11 degrees negative. And as an idle up 2, if you like that, you want a little bit more collective, so you'd set up probably a plus 13 to a minus 10. And then if you want a throttle hold, you'd set that for a minus 10 and a plus 13 or 14. A little earlier we removed the throttle or the carburetor arm. Now you want to put a ball through the hole and you want to reinstall it. You want to reinstall it so that this is the low speed position. It's got a spring to hold it in the low speed. So you want to reinstall it. Basically you have to flip it over from the normal setup, and then use blue thread lock on this. When you tighten it up, hang on to this so you're not stressing the carburetor butterfly or the main axle through the carburetor. Get that tight. Okay, for the throttle servo, you want to mount the control ball about 7.5 millimeters from the center. So that'll be a hole that's either very close, or you can drill your own at 7 or 8 millimeters, somewhere close to that. The throttle rod you want to make up so that from base to base of the control links it's 64.5 millimeters. Now if you've got all this set up right, and depending on what kind of servo you have, that length may be a little different. If you have it set up correctly, when the servo is in the center, the throttle arm will be in the center of its throw, or it'll be directly parallel to the carburetor. On the rotor servo, you're going to want to mount the bell crank so that it's as close to 90 degrees as you can. And an added nicety here is on the side of the frame, there's a cutout. And that cutout will let you get to the screw on the center of the servo as well as the ball link. And you'll be able to see that it's centered by looking through there. When the servo arm on the rudder is centered, what you want to do is adjust the lengths of the links on these rods until the rear tail rotor bell crank is at a 90-degree angle to the tail boom. It's roughly centered in this support bracket. You can be sure the bell crank's at 90 degrees if you fold the blades back like this and they both are in a parallel line to each other. This should be right at 90 degrees. If it is, then you've got everything as close to zero as you're going to get it. All right, now we're going to make sure the tail rotor is set up to move in the right direction. Go back to the tail rotor blades and position them like this. The one on the, you want to turn the blades so they're vertical, and then rotate the one at the top towards the front and the one at the bottom towards the rear. Okay, so what we're going to show now is if this is set correctly, if you move the rudder stick to the right, the top blade will point to the right. The bottom blade will point to the direction that the tail is going to be moving. And the same will be true if you move the stick to the left, the top blade's pointing to the left side of the helicopter, and the bottom blade is showing you the direction that the tail boom is going to move. If that matches, then you've got it set right. If not, you're going to need to reverse it in your radio. Same thing is true with the setup for the gyro. If you move the nose to the right, the blade should move to the left, and vice versa. If it doesn't set up, if it's not set up this way, then you need to reverse the gyro. For the rudder push rod, you want to get this as straight as you can between the servo in the front and the bell crank in the back. Once you've got everything set up, you want to do this by slightly changing the position on the standoffs. There's 4 of them. You'll need to use some finesse there to get them right. You can get it pretty much straight. Once you've got it the way you want it, or as straight as possible, use some thin CA and wick it under each of the 4 standoffs. That'll hold it to the boom, keep it from moving. All right, at this point the basic model setup is done. We've not looked at the throttle curve yet. I'm going to deal with that in the next section where we're going to deal with both throttle setup and initial engine tuning. Overall, the model's ready to fly. Of course, you'd want to fine-tune cyclic settings, pitch curves, exponentials, things that you normally set up the way you like. There are many more settings in the fly-barless controllers. We're not going to touch on that. The point here was to give you enough information to get the model flyable.